All right, let's talk about logarithms. Now, logarithms, they have nothing to do with logs, and they have nothing to do with rhythm. They involve exponents. And here's how they work. Let's say we have this expression, which we would call log base 5 of 25. It means what power of 5 is equal to 25. Now, since 5 to the second power is 25, log base 5 of 25 is 2. In logarithms, the base is the subscript, the little number next to the word log. The next number, the number we're finding the logarithm of, is the result of taking our base to a power, or to an exponent. The answer to our logarithm problem is the exponent itself. In other words, a logarithm takes the numbers in an exponential equation and just moves them around. Let's do another one. Here we have log base 3 of 243. So what we want to know is what power of 3 is equal to 243. This one's more difficult, and you'd probably want to use a calculator to get your answer. But I will tell you that 3 to the 5th power is 243. So log base 3 of 243 is equal to, that's right, 5. Still with me? Okay, let's bring a fraction into this. Say we have log base 2 of 1/8. We have to figure out what power of 2 is equal to 1/8. Now, the only way to get a number smaller than the base that we start with is to use a negative exponent. Since 2 to the 3rd power is 8, regular 8, 2 to the negative 3rd power is going to be 1/8, or 1/8. And that means that log base 2 of 1/8 is -3. A lot of times, you'll just see log and then a number without a base. When there's no base, when there's no little number next to the word log, the base is always 10. So when you see log 1,000, that means log base 10 of 1,000, and is asking us what power of 10 is equal to 1,000. We'll go ahead and do this one. 10 to the 3rd power is 1,000, so log 1,000 is 3. Whenever you're finding the log of a number that is just a 1 with zeros, all you need to do is count the zeros. So log 100 is 2, log 1,000 is 3, log 1,000,000 is 6, and so forth. So why do we bother with logarithms at all? Well, there's a couple of reasons. First, they can help us solve exponential equations. Let's do one of our old bacteria problems. Say we have a colony of 10 bacteria, and the size of the colony triples every hour. Now let's say we want to know how long it will be before we have 1,000,000 bacteria. We can set up this equation. Let's go ahead and divide both sides of our equation by 10. That'll give us 3 to the x power equals 100,000. Now, no one in the history of everything knows what power of 3 is going to give us 100,000, but we can use a logarithm to figure it out. Let's rewrite our equation as log base 3 of 100,000 equals x. We can plug this into a calculator and find that x is about 10.48. So that means after about 10.5 hours, our colony of 10 bacteria have grown into a colony of 1,000,000. Logarithms are also used in measurements. The Richter scale, which measures the intensity of earthquakes, uses base 10 logarithms. As a result, a 7.0 earthquake is 10 times more intense than a 6.0 earthquake. And an earthquake that measures 8.0 on the Richter scale is 10 times more intense than an earthquake that measures 7.0. There's a lot more we can do with logarithms, but I hope this gives you a good overview of what they are and how they're used.